Hello, everyone. I'm Electric Power Technology. In our daily work, we often encounter tripping accidents of residual current circuit breakers. Many friends do not know how to determine the cause of tripping of a residual current circuit breaker. There are three common reasons for tripping: short circuit, overload, and leakage. Leakage. Today, we'll teach you how to quickly determine the cause of tripping without any tools. Next, we will simulate the short circuit, overload, and electrical state of the circuit breaker, and then observe the fault phenomenon when it trips. First, let's use this high current generator to simulate the fault phenomenon of the circuit breaker tripping in a short circuit state. We increase the current to over 1 million amperes, and at this point, the circuit breaker trips. After the tripping, besides the circuit breaker itself tripping, there is no other action or change on the circuit breaker. Next, let's simulate the phenomenon of the circuit breaker tripping due to overload. The rated current of this circuit breaker is 20 amperes. We slightly increase the current because the temperature is relatively low now. The time for simulating overload tripping will be relatively longer, so we need to wait patiently. It has been a while. Let's increase the current a little bit more to make it trip a bit faster. This circuit breaker is a thermal magnetic breaker. It generates heat when overloaded and pushes a thermal deformation mechanism to make the circuit breaker trip. Let's touch this circuit breaker. Its side has already heated up a bit, so it will trip soon. Take a look. It has tripped now. Therefore, when the circuit breaker trips, if the side feels hot, we can basically determine that it is due to overload tripping. If it is due to short circuit tripping, it generally does not generate heat. Finally, let's take a look at the tripping phenomenon of the circuit breaker in the case of leakage. First, we use this circuit breaker to start a fan. This is the normal operating state, indicating that the fan is not a problem. Next, we will simulate a leakage circuit by connecting the line and neutral wires through this residual current circuit breaker, which monitors the residual current. This makes the circuit breaker detect a current indicating the leakage state. Let's close the circuit breaker, and you can see that it trips, and the blue button on top pops out. This indicates that if the blue button on top of this residual current circuit breaker pops out, it represents a tripping due to leakage